From the dawn of civilization, human beings have gazed up at the night sky with curiosity and wonder. Ancient cultures observed the stars, charted celestial patterns, and crafted myths about what lay beyond. Despite our limited technology in those times, the questions they asked were profound. What is out there? How did we get here? What lies beyond what we can see? Over millennia, these questions have remained central to our quest for knowledge. But today, thanks to the power of modern space science, we are beginning to get real answers. Answers that are transforming everything we thought we knew about the universe. One of the most significant contributors to this transformation is the James Webb Space Telescope, JWST, a marvel of human engineering and scientific ambition. Launched in December 2021, JWST represents the next great leap in our exploration of the cosmos, following in the footsteps of its predecessor, the Hubble Space Telescope. But where Hubble's strength lay in visible and ultraviolet light, JWST observes primarily in the infrared spectrum, allowing it to peer through clouds of gas and dust and reveal the universe's most hidden and ancient secrets. The telescope's capabilities are, quite simply, revolutionary. With its massive 6.5-meter gold-coated mirror and powerful sensors, JWST can detect the faintest glimmers of light from galaxies that formed over 13 billion years ago, shortly after the Big Bang. It's as if we've constructed a time machine that can take us back to witness the birth of the universe itself. And what it has revealed so far is nothing short of astonishing. One of JWST's most visually stunning achievements is its deep field image of a distant galaxy cluster known as MAX 647 JD. This galaxy was first discovered a decade ago using the Hubble Space Telescope, but with the James Webb's more powerful instruments, astronomers have now been able to study it in extraordinary detail. Through the phenomenon known as gravitational lensing, where the gravity of massive objects warps space and magnifies distant light sources, JWST has provided new insights into the structure, behavior, and composition of MAX 0647 JD. Scientists are still debating whether this object is a single galaxy or two merging systems, but one thing is clear. JWST is offering a window into the early stages of galaxy formation, a period of cosmic history we've barely begun to understand. But this is only the beginning. Webb has already shattered records by discovering galaxies that are older and farther away than any previously observed. One of the most groundbreaking is Sears 93316, which may have formed just 250 million years after the Big Bang. If confirmed, this galaxy would not only break existing records but also force cosmologists to revise their models of how quickly the first stars and galaxies formed. The redshift of Sears 93316 is an astonishing 16.7, meaning its light has been stretched by the expansion of the universe to an extreme degree. Preliminary analysis suggests this is not a foreground object or a false detection, but a legitimate glimpse of one of the very first structures to form in our universe. Even more incredible is the potential for JWST to detect galaxies at redshifts greater than 20, meaning they formed just 200 million years after the Big Bang. The implications of this are profound. For decades, we believed that galaxies took much longer to assemble after the Big Bang. Now, we are beginning to understand that the universe may have transitioned from the Dark Ages to the cosmic dawn far more rapidly than expected. These discoveries are giving us a glimpse into a time when the universe was still young, chaotic, and full of potential. Another exciting object observed by Webb is Able 2744Y1, a galaxy so distant that its light has traveled for 13 billion years to reach Earth. Using gravitational lensing and data from both the Spitzer and Hubble Space Telescopes, astronomers were able to identify this galaxy and study its rapid star formation. Despite being about 50 times smaller than the Milky Way, Able 2744Y1 is producing new stars at 10 times the rate of our own galaxy. This kind of activity is typical of early galaxies, which formed stars more rapidly than those we see today. It's discoveries like this that are compelling scientists to reconsider the processes behind galaxy evolution and how the early universe developed its structure. As we zoom out and consider the broader implications, the scale of the universe becomes almost incomprehensible. The observable universe, the portion we can see with our current technology, has a radius of about 46.1 billion light-years. However, based on measurements of cosmic microwave background radiation and general relativity, cosmologists believe the universe may be far larger, potentially over 23 trillion light-years across. Some theories even suggest that the universe may be curved or looped, making the visible cosmos only a tiny sliver of a much grander reality. Then there's the theory of cosmic inflation, the idea that the universe underwent a brief, explosive expansion right after the Big Bang. If this theory holds, it could mean that the observable universe is just one bubble in an infinite multiverse. During inflation, entire regions of space could have ballooned outward, each potentially developing its own physical laws, structures, and even life. Could there be other universes out there? Could they host alien civilizations governed by physics similar, or wildly different, from our own? These questions, once purely the domain of science fiction, are now at the frontier of scientific inquiry. Let's not forget GNZ11, a galaxy that until recently held the record for the most distant ever observed, located an estimated 32 billion light-years away. When accounting for the expansion of space, GNZ11 allows us to peer into a time when the universe was just 3% of its current age. What makes it particularly fascinating is that it sits near the surface of last scattering, the boundary beyond which light could not freely travel. In a way, GNZ11 represents the edge of the visible universe, the outermost limit of our current observational capabilities. As we uncover more about galaxies like GNZ11, Sears 93316, and Able 2744Y1, we begin to assemble a clearer picture of how the universe evolved. The James Webb Space Telescope is not only helping us trace the history of galaxies and stars, but also pushing the limits of what we thought was knowable. Each new discovery adds another piece to the cosmic puzzle, helping us understand how space, time, matter, and energy came to form everything we know today, including ourselves. In the grand scheme of things, our place in the universe may seem infinitesimally small. Yet the very fact that we can build instruments like JWST, interpret the light of ancient galaxies, and ponder the existence of other universes is a testament to human curiosity, ingenuity, and imagination. As we look deeper into space, we also look deeper into our own origins and our shared destiny. What do you think of these awe-inspiring revelations brought to us by the James Webb Space Telescope? How do they change the way you see the universe and your place in it? We invite you to share your thoughts and questions in the comments. If you're fascinated by the cosmos and want to stay up to date with the latest discoveries, make sure to subscribe, like this video, and turn on notifications. Thank you for joining us on this incredible journey through time and space. Until next time, keep looking up.